Alright, so this video is on coordination compounds. Which is actually on isomerism, optical. And so this is actually detailed. I'm going to start from the first compound, which is Ma4B2. Right. So Ma4B2, it's like this. The first one is like this. Now here B are opposite sides. Now next compound we can clearly see it will be adjacent B. These are not the same at all because A, B, A, B, A, or A, and here it's A, B, A, or A, B, B. So it's not matching. So 1, 1. 2 is the answer for Ma4B2. Now the next one. The next one is Ma4BC. This is also a bit tricky, but we can do it. First is just A, and then B and C. Here, this is one, and then B and C next will be opposite. Sorry, adjacent A and A. Now you can see here A, B, A, C. A, B, C, A. So not the same. 1, 1. And is this optically active? No, because we can cut it through this plane. It's symmetric, and this through this, that's symmetric. Now, can we think of another? Let's try. Now what if B and C are opposite in this plane? Actually, they are the same. Let's check it out. So these and these are same. How? Because see, BACA, then BACA. So basically the same as this. And just these two are the answers. So for Ma4B2 and for Ma4BC, the 2 is the answer. Now the next one. Next one is Ma4. Ma3B3. That's a bit hard. So here is M. A, B. And then B, B. So here we have AABA or ABBBA. The next one we are going to do something like sort of trans. And firstly let's check if this is symmetric or not. If we cut from this plane, it's symmetric. So no optical, optical, enantiomer pair. A, B, A, B. This is different. A, B. Now why is this different? Because your no square cycle can match. A, B, A, B, A, 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 B. Oh, it's matching. A, 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 B. A, 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 B. Okay, so this is not the answer. um, this is the only one till now. Now what if we place all A's together and all B's together, which means A should be on this side, B should be on this side. That is actually generalized in NCERT, known as facial and meridional. And let's try it out. A, B, B, B. So these are not the same at all. A, B, B, A. We cannot find that. And A, B, B. So this is 1 and that's 1. Now is this optical, enantiomer? No, because if we cut from this, A, B, B symmetrical. So 1 and 1 makes 2. We should be really confident. And this has 2. Alright. Now the fourth one is basically I'll have to shift it right there. Okay, it's visible. Now is MA3B2C. MA3B2C. Alright. M A A A. Let's see, and then B B C. And reason I did this was same this facial and then this, but instead of 1B there is C. Now you can see if we take this square plane A B B A, then this A B C. Now let's try to make another one using AC adjacent, or instead we'll just shift B and B opposite sides, because this can be never copied. A C. Yeah. Now here we can see this is not going to repeat. A B C A B A B A C A B C. No, so this is one, and another one. Now also let's try to find, yeah, this doesn't have any enantiomer, this also because we cut from there. And now the other one. Here we will try to do A, C, B, A and A, because here B, A, C are together. Earlier it wasn't. B, A, C, B, A, C, B, A, C, A, B, A, C, B, A, C, and here it is C, A, B, B, C, A. Okay, no, so this is also different, clearly. Now this will have 3. MA3B2C has 3. MA4B2 has 2. MA4BC has 2. MA3B3 has 2. So here the trend broke down. Now let me right here now. Next we have MA3BCD, which will be very rare in exam. But still, let's. Alright. Now I'll keep them in one plane. Then here B, C, D. Now, if we exchange, let's say D here and B here, let's see what is. To get the feel of it, how it works. So ACBD, ACDB, no, AAAD, AAAB, and ACAB, ACAD. So this is one. Yes, these are different. Now what if we replace C instead of D and then D? So the reason I guess this is not the same, we can in short see it confidently as C and D are opposite here, and here C and B are opposite, and A and D are opposite. Here A and B was opposite, so here D there, and then B here M, and then B here, A and C. This should be also different according to this logic. Now let's see. ADCB. Alright. ADCB, ADAC. Okay, now. Then ACAA. ACBD. Alright, this is also different clearly. Now, AA was opposite this whole time, AC was opposite, AD was opposite, AB was opposite. Alright, now let's try to find enantiomers, which I guess here they could be. So here we will cut this. Oh, this is 2s. This has its enantiomer. And this. Okay, this is also enantiomer. But see, I guess the catch is that I guess these will overlap. Enantiomer of this can be this. I mean, don't get me wrong, because you can read the order ACBD, ACDB, and then if we mirror image, then I guess its image will be DAAA and C and then B. Now your ACBD, ACDB, okay, ACAB, and okay. First of all, the mirror image should be non-superimposable. If we reverse this order, A and D, oh, it's the same, so we shouldn't have taken. How to check it's, oh, we have to cut it through this plane. Okay, this plane. So this is one itself. I was wrong. See, through this plane, if we cut it, A and A are symmetrically. And here also, if we cut through this plane, let me draw it properly. Through this plane, A and A are equally opposite sides. Here also, alright, A and A. So 1, 1, 1. Now let's try something different. Let's keep A and A there. A and A. and then the opposite A, opposite B, A opposite D, A opposite C, A opposite A. Everything was done, but we didn't rearrange anything. So here I'm going to keep C, let's say, B and D. Now this is A, B, C. And then earlier did we have it? A. Okay, we didn't, because earlier in the square there were 3 A's or no, or 2 A's, but not consecutively, because A, C, A, D, these A are not consecutive. A, C, B, D, these are not consecutive at all. We can still check. Here all A's are consecutive in any square. Let's take this square for an example. This has a consecutive, or this square which I've drawn earlier, or this square. A are consecutive here. So that's why this is a different compound but 2, because it's an enantiomer, as we cannot find a plane through which it is symmetrical. This no, this not, this also no. So we have 1, 2, 3, and 4 and 5. So 5. Why am I so confident in 5? I didn't go ahead because I have a book in which the number is given, but I am trying to prove that. So as a result we are going to remember, but also this should be clear how we calculated the number. And now the most tricky part in part 2.